والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Welcome to lecture number 11 in the psycholinguistics course. Today we are going to talk about language perception. We talked about that already in the previous lectures, and today we will be continuing talking about it. Basically, in the last lecture, lecture number 10, we talked about priming. What is priming? Remember, we talked about lexical decision tasks. Lexical decision tasks. In these tasks, we show people equal amounts of words and non-words. So, doctor, for example, is a word. Doctor here, cabin is a word, nurse is a word. And non-words. If you remember, znr, mrock, things like that. Those are not words. We show participants or people who participate in our research, we show them a word once. And then we ask them to tell us if this is a word or not. If it's a word, click this button. If it's not a word, click this button. So we show this word, cabin, for example, very quickly. We ask them to do that very quickly. And then the participant says, yes, it's a word. The computer registers how long it took this person to say, yes, this is a word, or no, this is not a word. This is called lexical decision tasks. Lexical decision task. In priming, we show a number of words, but in the middle, we have a related word, a word that is related to the target word. We call this a prime. We call this target. So first of all, we show this word nurse for 500 milliseconds. And then we show the word doctor. This is a related prime, isn't it? Because nurse, doctor, they are related semantically. And then we show other words, and then suddenly we show this prime, cabin, for 500 milliseconds. Half a second. All right? Cabin, and then we show the word doctor. And then we measure how long it took people to answer, yes, this is a word here, if it's preceded by a related word, and how long it takes them here to respond to this word doctor if it's preceded by an unrelated prime, a word that is not related. Usually this is faster. We respond faster if the preceding word is related. This is called priming. This word primes this word. It makes it active. This word makes this word active. Right. Example, students. So let's say that we are going to show you, I'm going to show you here a number of words, maybe 100 words, all right? But in the middle, I show you this blank, then student, then teacher, car, duck, all right? Now, student, then teacher. Usually people here, what will happen when we ask them to judge whether this is a word or not? Do they answer faster or faster or slower? It's faster. Faster, because the preceding word is a related one. Student, teacher. But then if I show participants car, duck, are they related? Not really. So here response will be slower. Response time will be slower for the word duck because it's preceded by the word car. When someone says car, you don't imagine a duck, right, in your head. So it's unrelated. It doesn't make it active. When I say car, maybe other words related to car will come to your head, right? When I say car, you might think of drive, driver, a traffic light, traffic jam, tires, things like that. Maybe some models, some car models, car manufacturers as well, things like this. Right. So this is just an example of priming. Now, what types of priming do we have? Overall, we have two kinds of priming, two basic ones. The first one is called semantic priming. Semantic, it has something to do with meaning. Semantic has something to do with meaning. So semantic priming, or associative priming. Associative priming. So associative means to associate one word with another. They are associated in meaning. So semantic priming, that's number one. Number two, we have form priming. What is meant by semantic priming and form priming? What are the differences between the two? This is what we are going to see right now. First of all, semantic priming. This happens when there is a meaning relationship between the prime, the first word, and the target word. Let's imagine that I'm going to show you here a number of words. Those are just screens. All right, so that's number one, that's number two, it's number 3, 4, 5. Right. Now, so first of all, I'm going to show you this word, maybe car. Then drive. Okay. Then probably house. Then morphine. All right, and then here whatever. All right, now car. So first of all, I show the word car for 500 milliseconds, half a second, and then I take it away and I show you the word drive for another half a second or 500 milliseconds. Drive. Now, do you think this will affect this? Will affect how quickly you answer, you accept or reject this word? So first of all, I show you this word, car. You say, yes, it's a word. Then I show you the word drive. Usually, this word, the first one, car, should make it easier for you to answer that drive is actually a word more quickly. So you answer more quickly, to this word, drive. You respond to it quickly. Then I show you the word house. After that, I show you the word morphine. Are we going to have the same effect here? So this effect here, which is fast answer, quick answer, are we going to see it here, morphine? Probably not, because house, morphine, they are not related to each other. So, yeah. But here, there is a semantic priming here between the two. because there is a meaning relationship between the prime, this is prime, and, or the first word, and the target word. This is my target. This is what I want to test. Alright, so I put a lot of words, but this is the one I'm interested in. I don't care about the others. I just want to see, will participants respond to the word drive more here, or if when it's preceded by an unrelated word. Say, for example, let me just try that. All right, let's say logic logic and then drive, for example. And here in the middle you will have a lot of words in the middle. Alright, so here the word car, then drive. I test how long it took participants to say, yes, this is a word. Maybe, I'm just assuming that they will answer in 200 milliseconds. And then I show participants a lot of words. And for each one, they respond variably. Yes, it's a word. No, it's not a word. And then I show them the word logic, which is not related to the word drive. And then I test again how long it took participants to say, yes, this is a word, the second time. But the difference here is that it's preceded by an unrelated prime. So I calculate again how long it took participants to say this is a word. What we found is that probably people will answer in 400 milliseconds, not 200 milliseconds like there, just roughly. Yeah, because logic, drive, they are semantically not related. They are semantically not related. Let's look at these examples. Here we have examples of words that could possibly give us what we call priming effect. So for example, student, teacher. They come from the same semantic field. The same semantic field. So student, teacher, school, things like that. Words that are related to the same semantic field. Drive, car. Also, they are related, aren't they? Drive, car. Also, driver, for example, traffic, things like this. Those are related to the semantic field. Mobile, phones, nurse, doctor, hospital, needle, maybe, X-ray. Words that are used in health sciences. So nurse, doctor, things like this are related to the field of medicine. They are from the same field. We have some words that are mainly used in education or in physics or whatever. So we call them semantic fields. So those are some examples. Now compare a word or a prime, student, followed by teacher. How do you think people will respond to the word teacher? Faster or slower? Faster, because they are related to the same semantic field. But let's say first I show the word student, and then car. I show student and then car. Do you think there will be an effect? There will be a priming effect? No. there will not be a priming effect because student is not semantically related to the word car. Okay, it's the same. Drive and doctor. If I first show the word drive and then I show the word doctor, they are not from the same semantic field. So again, we will have the same, not problem, but there will be no priming effect. Priming only happens when there is a relationship between the two words. Right. Now, we talk about form priming. Remember, there are two types of priming. The first one is semantic priming. We already talked about that, when there is a relationship between the prime and the target. Number two, we have form priming. Form, what do we mean by form? That's the first question some students would ask. Form means a word, a part of a word, such as morpheme and so on. So, here, the prime and the target are not related semantically, or in meaning, but are related in their phonological form. In phonology, they sound the same. So words that sound the same. This is called form priming. Do we have examples here? Yes, we do have some examples. So here are some words. First of all, cake followed by lake. Now my question is, do you think if we show participants or people the word cake, and then we ask them, is it a word? They say, yes, it's a word. And then we show them the word lake. Do you think that they will respond to lake faster if it's preceded by the word cake, which sounds the same? Or they will respond faster if it's preceded by a word that does not sound the same, like gap? So number one, cake. Then lake. Number two, we say, for example, gap, then lake. Now, which one do you think they will respond to faster? Here or there? Which one will be faster? The answer is number one. They will respond faster to the word lake here than here, because here it's preceded by a word that sounds the same. So cake, lake. Fake as well, also as another example. Bake is another example. So cake, bake, lake, and words that sound the same, will give us what we call priming effect. Also, gap and map. Gap and map. They sound the same, don't they? We only have the first phoneme difference. The only difference is the first phoneme. We have other examples like bell and cell. Bell and cell. Sling and bring. Sin, win. And so on. So words that sound the same will prime other words. So when I say cake, like your brain remembers or let's say activates all the words that sound the same, like cake, lake, fake, bake, and so on. All of them will be active for you to choose from, for lexical access, for you to choose a word to use, for understanding or for production. So it works this way, but it doesn't work like that. So when I show gap and then I show cell, there will be no form priming. Maybe there is semantic priming, but it's not here. Alright. Now here is simple priming. When I showed you the word, for example, student, teacher, car, duck, this is called just priming. Let's look at the first example here. So let me just erase that. If you notice here, there, all of the words are shown in 500 milliseconds only 500 milliseconds. But there is something that is called masked priming. Masked priming. So the prime here, the first word that we will show, will be presented so briefly that it is not consciously processed. How do we do that? But will still result in the priming effect. In this technique, this is how it happens. The prime is sandwiched between a mask, like this one, and the target. What does that mean? So, first of all, we show the mask, which can be, for example, this hash sign. All right. So we show this for 500 milliseconds, half a second. We show this mask. And then we show the prime word, which is table. We show it not for 500 milliseconds, only for 50 milliseconds. Only 50 milliseconds, which is impossible for you to consciously notice. So you will not see the word table. You will not see it. And then after that, I show the target, the word that I want to use, like fable or table. All right? And then I show it for 500 milliseconds. For 500 milliseconds. And then I ask this question. Now I showed this prime table for 50 milliseconds, which is impossible to notice consciously. Maybe unconsciously we notice it, but not consciously. The question is, will this word, which is shown for only 50 milliseconds, will it give us a priming effect? Like people will answer to this more accurately? Here the mask. This is the mask. And the target, this one here, the mask and the target will be shown in 500 milliseconds. All right, but the prime here, 50 milliseconds. So this is not enough time for the word to register consciously. People generally report seeing a flicker only between the mask, between this and this. but they don't say we saw this word table. No. However, yeah, so it is apparently enough time for the stimulus here to prime the following target. So even showing words for a very quick period gives us this priming effect. The question is, will non-words give a priming effect? So if I, for example, show this mask here, let's say it's whatever, okay, for 500 milliseconds, and then I show a non-word like fable, and then I show it only for 50 milliseconds. Then I show people the word table. Or let's say no. Let's choose another one. Let's choose this example that we have here. So here, for example, we have Doctor, for example, which is not a word. All right, but it sounds like doctor. So doctor, doctor. Those are replacements for the word doctor. We show it for 50 milliseconds, and then we show people this word. Sorry. All right, so we show nurse, for example. So we know that doctor will prime nurse, so people will respond faster to nurse if it's preceded by doctor. But what if I show the word doctor, which is not a word, for 50 milliseconds, and then I show this for 500 milliseconds? So first of all, I show the mask, 500 milliseconds, okay, not a word. Then doctor for 50 milliseconds, no one will notice it. And then very quickly, we'll have the word nurse. What we found is that, yes, there will be a priming effect even for non-words, even non-words that sound the same as real words like doctor. Both will give us faster responses. All right, so overall we have two types of priming: semantic priming and form priming. Semantic priming is when we have meaning relationships between the prime and the target. And here are some examples. Then we have form priming, so phonological form priming, when the two words sound the same, like here. We have a new priming method which is called masked priming method. It should be masked priming method. All right, so the prime here and the word, the prime is shown for 50 milliseconds, very brief amount of time. And then before that we show the mask, any symbol, then the prime for 50 milliseconds, and then the target. This is what we are focusing on. So what we found is that, yes, there is an effect for the prime even if it's shown for 50 milliseconds. So that gives us an idea about lexical items and the fact that they are organized, lexical items or words in our lexicon are organized by their sound and meaning together. And that's how we found semantic priming and form priming. I hope that you found this lecture easy to understand and easy to follow. It's a little bit shorter than the other lectures, so probably if it's not clear, you can ask me in the live session, the coming live session, or send me an email and I'll be there to answer you, inshallah. Thank you very much for your attention and see you in the coming lecture. Assalamu alaikum.